a matter of physics.
Hey guys, and welcome to this awesome video about classical mechanics, where you can learn how to calculate velocities and why things get faster when they fall to the ground. But first, let us introduce you to Tom. Tom will help us to get through this video and make things more understandable. But what even is classical mechanics? Classical mechanics describes the motion of objects in the classical regime. That means the results and laws are always valid in our everyday life. If you think, oh, this is quite easy, well, there are exceptions. If an object is either really fast, small or dense, the laws of classical mechanics aren't valid anymore. Now to the first small topic, reference frames. So, what is a reference frame? A reference frame is like a coordinate system attached to something. If we measure or calculate the motion of an object, we measure it with respect to some kind of reference frame. The result of our measurement depends on the choice of reference frame. The most common reference frame is called rest frame. Your rest frame is a coordinate system attached to your head. Remember what we said before? In this reference frame, the object under consideration is at rest. Imagine Tom sitting in a car. The world around him seems to move, but actually, he is moving. In his rest frame, he is always at rest, even when he is moving. We're sorry, but there are more kinds of reference frames. Center of mass frame, laboratory frame of reference. Oh wait, that was way too fast. Let us explain. The center of mass frame is a reference frame where the center of mass of an extended object lies at the coordinate system's origin. The important thing is that there is no translation, only rotation. As an example, a football during a match does not move upwards, downwards, backwards or forwards, but it constantly rotates. The laboratory frame of reference is simply the rest frame of the apparatus we perform an experiment with. At least one easy thing to remember, right? To learn what velocity and acceleration are, stay tuned and watch this video. Also, don't forget to thumbs up and subscribe down below. Make sure to check out our Instagram at Matter of Physics. #shameless self-promo. Okay, now back to the video. To be able to calculate speeds and velocities, you must know what distance and displacement are. The displacement is defined as the change in position of the object. So, when Tom gets up from the sofa to get a snack out of the fridge and then goes back to his position on the sofa like before, his displacement is 0 meters because the starting point and the end point are the same. But there is another thing, the distance traveled. Let's say Tom walks 10 meters to the fridge and 10 meters back. His distance traveled equals to 20 meters. The distance is the length of path the object, like Tom, actually takes. There's an important difference between the displacement and the distance traveled. The displacement is a vector with both magnitude and direction. If you don't know what vectors are, you should watch the movie Despicable Me. Maybe it will become clear then. I go by the name of vector. It's a mathematical term represented by an arrow with both direction and magnitude. Vector! That's me, because I commit crimes with both direction and magnitude. Oh yeah! But what is important in physics is that the displacement can be positive or negative. It depends on the direction. On the other hand, the distance traveled is always positive. With these two things, we can now calculate the speed or velocity of objects. The average speed is defined by the distance traveled divided by the time elapsed. It refers to how far an object travels in a given time, regardless of its direction. The velocity is linked to the displacement, so it shows how fast an object is moving and the direction in which it is moving. The average velocity equals to the displacement divided by the time elapsed. In this video, we will mainly focus on the velocity, not the speed. In mathematical terms, the average velocity is defined by average v, which is given by delta s divided by delta t, and that is equal to s1 minus s0 divided by t1 minus t0. The unit is meters per second. This is also used for speed. Now to show the differences again, we have a quick review. Speed is a scalar, so it has no direction. It is always a positive number, whereas velocity can be positive or negative. The sign gives information about the direction. Another thing to remember, you often have to convert kilometers per hour to meters per second or vice versa. These numbers help you to do this in about 2 seconds. Let's go deeper into the topic velocity. Until now, we have always thought about an object moving with the same velocity the whole time, but as you can imagine, this is hardly ever the case. As an example, when Tom goes to school in the morning, he thinks he has a lot of time left, but 2 minutes before school starts, he still has a long way ahead of him. He starts sprinting and becomes faster and faster. What, for example, is his velocity 30 seconds before he has to be in the classroom without being expelled? Well, there's a thing called instantaneous velocity at a certain point of time, which you can determine geometrically with the slope of the tangent to the s versus t graph at time t. The instantaneous velocity is defined by the change in velocity over the change in time. Now to the next topic, uniform motion. We speak of uniform motion if the velocity is constant. The distance as a function of time is s equals to s0 plus v multiplied by t. S0 is the initial position at time t0. This function is a linear function. Yep, math has found its way again. Here you see the graph in a position versus time graph. This next graph shows the velocity in a velocity versus time graph. You see, the velocity is always the same. When you think about the example before, the one Tom sprinting to school, there's another important factor, the acceleration. Acceleration means that you change the velocity. Average acceleration is defined by the change in velocity divided by the time elapsed. In mathematical terms, this is average A defined by delta V divided by delta T, which means V1 minus V0 divided by T1 minus T0. The unit of acceleration is meters per second squared. Acceleration is represented by a vector, so it can be positive or negative. As well as for velocity, there's also uniform acceleration. This means the acceleration is constant. Now you have to listen carefully, as we will talk about important formulas and how to derive them. In this coordinate system, you see the acceleration versus time graph. As you can see, the acceleration doesn't change over time. Let's say at time equals to 0, Tom accelerates with constant acceleration. This actually means he gets faster over time, but his acceleration is always the same. To be able to understand this, you have to look at the velocity versus time graph. At time t, the velocity is v as a function of t, or short v. The connection between a and v is a equals to delta v divided by delta t, which is equal to v minus v0 divided by t minus t0. This is equal to v minus v0 divided by t. If you solve for v now, you get v as a function of time equals to v0 plus a multiplied by t. This graph shows the position versus time graph. The average velocity is v average equals to v0 plus 1.5 a times t. You travel the same distance in time t with constant velocity v average. The distance traveled is s as a function of time equals to s0 plus v average times t. So if you plug in the average velocity in this formula, you get s as a function of time equals to s0 plus v0 times t plus 1.5 a t squared. Quite difficult to understand, right? And there's even another formula. Because if an object with velocity v0 accelerates with constant acceleration between position s0 and s1, the velocity at the end position is given by v squared as a function of time equals to v0 squared plus 2a multiplied by s minus s0 in brackets. To be able to memorize that, you can see all the formulas we've talked about here for an overview. Okay, now that you know all these formulas, we can go a step further. You have probably asked yourself at least once in your lifetime why all things fall to the ground, even if you throw them upwards. Isaac Newton, one of the most important people in science, also thought about this phenomenon. There's a force, called the gravitation, which pulls all objects to the center of the Earth. So, all objects get accelerated to the ground. This is called gravitational acceleration. On the Earth's surface, the acceleration A is negative 9.81 meters per second squared, because it goes down, so the gravitational factor G is 9.81 meters per second squared. Until now, we've just spoken about motion in one direction, but what about an object moving both upwards and to the right at the same time? This is another topic called projectile motion. In this topic, vectors are very important. So again, if you don't know what these are, you should go watch a video about them here on YouTube or have a quick look on Google. We won't explain what vectors are in this video. As we said before, vectors have both direction and magnitude. The topic we will talk about requires knowledge about trigonometry and the trigonometric functions. If you don't know what sine, cosine and tangent are, you should also have a quick look at the video here on YouTube. But let's start. Here you see the motion of an object, which gets thrown upwards and to the right at the same time. For example, Tom throws a tennis ball to his friend. Well, how can you deal with this motion? First of all, it is important to know the initial velocity v0 and at which angle the v0 vector is. Let's say v0 is 100 km per hour and the angle alpha equals to 60 degrees. You can draw the vector here. It doesn't matter how long it is, but it should start at the initial position and also be a tangent to the parabola. In this case, the initial position is the origin. With the trigonometric functions, you can easily calculate the components of the vector. The x component equals to v0 multiplied by cosine of alpha. You can see this in the coordinate system here. The y component equals to v0 multiplied by sine of alpha. So the velocity vector v0 equals to v0 cosine of alpha in x direction and v0 sine of alpha in y direction. Not too difficult, right? But you want to find out how the x and the y components change over time. For this, you have to know that in order to change the velocity in a certain direction, there has to be an acceleration in this direction. In the x direction, there is no acceleration. We ignore air drag. But in the y direction, there's the gravitational acceleration which pulls down the object. Hope you still know what that is. You can determine the components of the velocity vector as a function of time. Vx as a function of time equals to Vx0 equals to v0 multiplied by cosine of alpha. And Vy as a function of time equals to Vy0 minus gt equals to v0 sine of alpha minus gt. The x component is a function of uniform motion. The y component is a function of uniform acceleration. Not everything we said before was worthless. Now we see that the velocity vector is. The corresponding components of the position vector as a function of time are x as a function of time equals to Vx0 times t equals to v0 times cosine of alpha times t, and y as a function of time equals to Vy0 times t minus half gt squared equals to v0 times sine of alpha times t minus half gt squared. You put the two components together and you see that the position vector is. With this, you can also determine the total time of flight of the ball, the maximum distance and the maximum height. The formula to calculate how long it takes the ball to get from Tom to his friend is t equals to 2 times v0 times sine of alpha divided by g. To calculate the distance between the two friends, you can use the formula S max equals to v0 squared times sine of 2 alpha divided by g. And for the maximum height, you use y max equals to v0 squared times sine squared of alpha divided by 2g. Keep in mind that g is always positive. We know, these were a lot of formulas now and we hope you understood most of them. You can go back and watch parts of the video again if you aren't sure about certain things. But you made it to the end of this video. Thanks for watching and subscribing to our YouTube channel. Oh, and Tom wants to say goodbye as well. Don't forget to check out our social medias and stay tuned for further videos. See you all in the next one. Bye guys!